question 6. So we've got to get our diagram sorted. So the particle is travelling up the plane. We have our weight of 0.3 g broken down until its two components, and we've got the friction going the opposite direction to the motion. So for part 1, calculate the distance P moves up the plane. So in order to do this, we're going to have to work out the acceleration of the particle, and therefore we're going to have to rely on Newton's second, F equals ma. So first things first, as it's going to come into play as a component of the friction, we're going to need to work out the normal reaction here. Well, R equals this component of the weight, so R equals 0.3 g cos 30, the adjacent side. So R equals 2.546, which we're going to need in a minute. So now resolving up the slope, we've got our net force, which is in the opposite direction to the movement, hence why I'm choosing to make it negative. So our forces down the slope are both this component of the weight, so 0.3 g sin 30, added together with the friction, which is mu, the coefficient of friction 0.15, times the normal reaction, which we've just worked out to be 2.546. So our net force is this. So I'm calling this a negative force because it's, as I said, opposite direction to the motion. That equals the mass times the acceleration. The mass is 0.3 kilograms, giving us a deceleration of minus 6.173. If you choose just to make this positive, so you've got you come out with an answer of positive 6.1173, you'll still get full marks. But of course, as you move on to the next bit, you must appreciate that it's a deceleration and use a minus down here. So moving on, we're trying to work out the distance. We've done the hard bit, we've worked out what the acceleration is, or deceleration. At the top of the bounce, just before we start coming down again, v is going to equal 0. Our initial speed was 4, we're given that. So using v squared equals u squared plus 2as, this allows us to work out that the distance up the plane is 1.30 meters. Now, part 2, find the time taken by P to return from its highest position on the plane to the foot of the plane. So I think another diagram is helpful here. So as we start moving downwards, obviously our weight stays the same, and the components of weight stay the same, but the friction is now opposite and acting in the opposite direction. Remember, friction always acts in the opposite direction to the movement. The particle is now moving down, so the friction is upwards. So again, using Newton's second and resolving down the slope, our net force now is going to be the weight component of 0.3 g sin 30, take away the friction. So take away the 0.15 times 2.546. This equals our mass times acceleration, 0.3 times a, giving us a new acceleration of positive 3.63. Now for the journey downwards, remember at the top of the bounce the speed is 0, so our initial speed is 0. We know we travel down 1.3 meters and we're accelerating at 3.63. So using s equals ut plus half at squared, we get a time of 0.845. And finally, for part 3, we're looking for the change in momentum. So we've got an initial speed going upwards of 4, which was given, a final speed coming downwards of 3.07. That had to be worked out. I used v equals u plus at, so coming down I had initial speed of 0, an acceleration of 3.63 and a time of 0.845. So our final speed coming downwards was 3.07. Our change in momentum is mv minus mu, or factorising mv minus u. So if we're saying coming downwards is positive, we've got a final speed of 3.0 and an initial speed of minus 4. So it's 3.07 minus 4, so 0.3 times 7.07, which is 2.12.